Welcome to lesson 1.6. We are going to talk about transforming functions today. This is where you're going to take an equation and you're going to move it left, right, up, down, reflect it, stretch it, all those fun things. So here is your guide to how to tell if a function has been moved left, right, up, down, stretch, compress, etc. So the main thing to kind of look for is the location of the number that has been added, subtracted, what have you, to the parent function. Okay, so I try to give some examples here on this right side to kind of give you an idea of what you might see. But the big takeaway I think that will be the most helpful is that if you have a number that is being added or subtracted or a negative that has been applied to the outside of your function, that is going to indicate some sort of vertical movement where either it's up, down, or a vertical flip, like over the x-axis. However, if you see a plus, minus, or a negative applied to the inside portion of your function, you can look over here to the right if you want to know what that means, then you are describing a horizontal movement. And that means you're moving either left or right, or you're flipping the graph across the y-axis, which would be like kind of a side-to-side flip. So you're going to refer back to that cheat sheet quite a bit. I realize I just skipped over a page with dilations, but we will come back to that momentarily. So for now, let's go ahead and start. We are going to now see directions that ask us to graph a parent function, which is one of the reasons why it's so important for you to have those parent functions memorized, okay? So you're going to graph the parent function, which, again, you probably don't have them memorized yet, but that needs to happen soon. Bear with me, I'm using my airliner and it's really hard to draw a straight line. But this is my parent function. I'm going to label it f of x because that's what it says to label it as in the directions. And then it says graph g of x if that's the absolute value of x plus 2. Now because this plus 2 is on the outside, that is going to mean we need to move our graph up 2 spaces, which is very easy to do. You literally just take one point at a time and move each point up 2 spaces and you're done. Okay, just move each point up 2. So not so bad, right? Make sure that you label the new function by the name given in the direction, so g of x. Okay, here's the second one. We got g of x equals x squared. So we're going to graph x squared, which is a parabola. And again, it would be helpful to know key points on that parabola. So I need a U shape. I'm going to do my best here. Okay, and that's called g of x this time. And we're going to shift that graph down 3 spaces. I know it's down 3 because there's a minus after the x squared, which means it's a vertical movement. So down 3 spaces for each of these points. When I do this, by the way, I like to just move one point at a time, move each one down 3, and then draw the graph. Okay. There you have, and this one's called h of x. Okay, so now we're using x cubed as our parent function. That's the one that looks kind of like a, I don't know, an S-curve. So I'm going to label my key points, then I'm going to do my best to make this look. Oh my goodness. You guys, my handwriting is so terrible on this thing. Sorry. So that's supposed to be x cubed, which we're going to name f of x. And then this one's different. Do you see how there's a minus 2 inside the parentheses and then the cubed is on the outside? So anytime you have a function that has been changed inside where it's directly affecting the x value, that's going to indicate a horizontal movement. And if you look back at your reference sheet, minus 2 inside of parentheses like this would refer to a right movement. So we're going to move this graph to the right 2 spaces. And then we're going to see if I can do a little bit of a better job here. Okay. That's a little bit of an improvement from the last one, don't you think? This one's called g of x. All right, one more here. We have, the square root function. Okay, square root function is one that starts at 0, 0, it goes to 1, 1, and 4, 2. Do you know why the square root function doesn't go to the left side of the graph? That's because square roots can't be negative. If you get a negative square root, you have an imaginary number, in fact. Okay, what do you think about this one? This one we have a +3, but there's no parentheses, so that doesn't really mean it's horizontal, right? Well, the +3 is inside of the function itself, and anything that's inside the function or affecting the x value directly is actually a horizontal movement. In this case, it's left. The reason why there's no parentheses is because the square root kind of serves as parentheses. It holds everything in. So you don't really need parentheses here to indicate that it's happening within the square root. So once we know it's left 3, the rest is pretty easy, right? Just move it left 3 and you're done. And this one is h of x. Okay, so this one, the graph of the parent function is translated in each of the graphs shown below. Find an equation for each of the transformations from the parent function. So it's already been moved. Okay, it's already been moved. Obviously, you can tell it's an absolute value function by the way it looks, but it also does tell you that it's an absolute value function in the directions. So I think maybe it would be helpful, at least for me anyway, to draw the parent function. And I don't know, it's just a personal preference, but I'm a very visual person. And so it helps me to have the parent function here in front of my face so I can see exactly what's changed. So if I'm starting from the green function and I'm moving to this black function, it's very clearly shown that it's moved to the right 1 and down 2. Okay, to the right 1 and down 2. So I need to write an equation that shows move right 1 and go down 2. Okay. Now, right 1 would have to go inside the absolute value because it's a horizontal movement, and we would say minus because minus means right. And then down 2 would be a subtracting 2 on the outside. So that would be your answer for 5. This one is the same thing, but this one obviously has been flipped, reflected. So we get the parent function on here. And then I'm going to kind of play around with this. So here's my parent function. Obviously, it has been reflected, right? Uh-oh. Let me try that again. Okay, my parent function has been reflected. Don't mind the dots not moving, but you get the idea. So my graph would be down here, and then it gets moved left 2 and up 3. Okay, so let me go back. I need to say reflect, and then left 2, up 3. And then left 2, down 3. All right, so we have to come up with an equation that shows all these things. Now, it is important to note it is being reflected over the x-axis, and that does matter because our negative placement is going to tell whether we reflect vertically or horizontally. So to reflect vertically, we need a negative in front of our entire function. To go left 2, we need +2, but inside the function itself. And then to go, oh, it's not supposed to be down, up. Oh my goodness, I'm losing it. It's supposed to be up. And to go up 3, you should have +3. Okay, same thing here. We're going to do our little graph, and then we're going to actually add a step where we have to find the domain. So I'm going to throw my parent function up. and this is called f of x. And then I'm going to do my transformations. So I have a negative, which means, and it's on the outside, so that is going to represent a reflection over the x-axis. Basically, it's going to flip down. And then the plus 2 is not inside the radical itself, so the plus 2 is going to indicate up 2. So I need to reflect and move up 2. Now when I do this, I'm going to move 1 point at a time. So I'll start with this origin value. I can't reflect it because it's already on the axis, so I'm just going to go straight to moving it up 2. 1, 1, the point would move to here if I reflect it, and then I'm going to go up 2, which is weird because it goes right back to where it was. And then my third point, if I reflect it, would move down here, and then up 2 is going to take it right to the x-axis, and then I'm going to try to draw my graph as best I can. And this one is g of x. The added step is we're finding the domain of our new function, and remember domain is x values. So this one appears to be, starts at the x value of 0 and goes to infinity. Next question, still referring to the square root function. So let me get this up. Parent function, done. And we are doing a reflection again, but which way is it reflecting? If it's inside, if the negative is inside the function, this is a y-axis reflection. So that's like flipping side to side, okay? Flipping side to side. So my graph will look like this. This is called h of x. What's my domain for this one? Well, my domain is, it points to negative infinity because it's the left side. So negative infinity, and it stops when x is 0. Okay. Square root again. So there's my parent function. Now this time we have to do two things. We have to apply the negative on the outside, which means to reflect it over the x-axis, meaning like flip it down. And then this plus 2 is on the inside, which indicates a horizontal movement, and plus means it's moving to the left. So we are going to flip it and move it to the left, 2 spaces. The origin won't flip, so you just move it to the left 2. 1, 1 will flip to here, and then left 2. And then 4, 2 will flip to 4, negative 2, and left 2 spaces. Okay, that's called k of x. Domain is x value to x value. So this one is looking like negative 2 to infinity. I'm going to pause here and go to another video to show stretches and compressions.